Okay, ladies and gentlemen, we are now going to look at alkenes. The other name of alkenes is called olefins. They are called olefins. That is the other name of alkenes, and they contain at least one carbon to carbon double bond. So one, we should know that alkenes, they are also called olefins, and they must have at least one double bond. So any compound that doesn't have a double bond, so it means that it is not alkene. And they have a general formula of CnH2n, and the N value starts from 2 or 3. So, and they are classified as unsaturated hydrocarbon. Compound with double bond or triple carbon bonds that enable them to add hydrogen atoms. So they are unsaturated because they are deficient in hydrogen atoms. So we should know this. And in addition, they have sp2 hybridized. They have sp2 hybridization. So under these alkenes, these things are important. Number one, they are called olefins. They must have at least one double bond, and they have a general formula of CnH2n. Then the value of N always starts from 2. So alkenes doesn't have a one carbon compound, and they are classified as unsaturated hydrocarbons. And examples of these alkenes we have, okay, and in addition, they are also considered as unsaturated because they have the efficiency of hydrogen atoms, and they are sp2 hybridization. They are sp2 hybridized, and when we have a value of N equals to, when we have our value of N equals to 2, and if we now substitute this in a formula, in this formula, we have C2, and 2 times 2 we have also will obtain C2H4, and this C2H4 is called ethylene. Because why is it that it is ethylene? It is in because it contains one double bond, so it is ethylene. So then next thing that we are going to look at is the naming of these alkenes. The naming of alkenes. Naming of alkenes, and it is very, very important to know the rules in naming these alkenes. So number one, the first thing you need to do in naming alkene is to select the longest continuous carbon chain that contains a double bond. So you see, if you count it from here, 1, 2, 3, 4, 5, 6, we have 6. So this chain contains 6 carbon atoms. But if you count it from here, 1, 2, 3, 4, 5, 6, 7, 8, we have 8. So it means that the longest carbon continuous chain is 8. So we should know that is not only, remember from the previous videos, I told you that if you have any organic compound, it must contain 3 components: prefix, then the root name, and then the suffix. So in this one, we are trying to identify the parent. So you see, if you follow it in this way, we have 8. So, but this compound, as you will an alkene, but change ANE to ENE for an alkene. So because of this double bond, of course, it will change. So you see that if you count it from here, 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 you see that we have 8. So the name parent compound is octene, not octane, because of this double bond. And the select is as a parent compound. So we select it as a parent compound because it is the longest carbon chain. So remember, if you are naming organic compound, the best thing, always try to select the longest carbon chain. You see the initial one, when we counted, it gave us 8. Sorry, it gave us 6. So we didn't select it because the longest carbon chain there is 6. But if we count it in the other direction, we have 8. So because the 8 are higher than 6, that is why we are selecting the one with 8 as a parent. Then the next thing is number the carbon chain of the parent compound starting with the end nearer to the double bond. So use the smaller of the two numbers on the double bond carbon to indicate the position of the double bond place. Place this number in front of alkene name. So you see, we have to number 3 rules. We have to number the number of carbon. So look at it. This is the carbon. So the end of the carbon chain is closest to the double bond, beginning numbering here. So because if you look at it, this is the carbon that are very near to the carbon bearing, that are very near to the double bond. So that's why we are starting here. We cannot start here because we always try to get the carbon with the lowest number. So we can only start from here, but we cannot start it from here, because if we say we started from here, it means that the position of the double bond will be indicated at carbon 7. So that is why we have to start from here. So we number this as 1. We will start with numbering this as our number 1 carbon. Then we then move to this 1, 2. Then we now move to 3, which is this one. Then we move to 4, like this one. Then we move to 5, this one. We move to this one. Then we now move to also this one, 6, 7, then 8, 9. Sorry. Okay. Yes. 1, 2, 3, 4. Yes. This one is 5. And this one is 6, and this one is 7, and this one is 8. So that is this. So then the next thing now is look at it. This is how it numbers. So it means that the name of the parent compound is 1-octene, and it can be 1-1-ene. It can be like that. So then after indicating the longest carbon chain, then the next thing that we are going to do is actually the branching and other groups that are actually attached as a substituent in the carbon chain. So look at it now. This is actually the branch. This is a branch where we have ethyl. This is ethyl. So after counting, you see that 1, 2, 3, 4. So at carbon 4, we have ethyl. So that is why we have ethyl 1-octene. So that is the name. That is the correct name. Remember, you cannot start from here. 1, 2, 3, 4, 5. You cannot start from here. 1, 2, 3, 4, 5. You cannot start numbering from here. Because if you start numbering from here, it will give you 5 ethyl oct 5 ethyl 7-octene. So you see that the number is longest. Look at it. Let me just write it. The numbers are high. Okay, yes, the number are high. Why is it that it is high? Because if you count from here, you see 1, 2, 3, 4, and this one is 5. So it means that the ethyl is at carbon 5. So we have 5. We have 5 ethyl. We write ethyl here. We write ethyl, 5 ethyl, 5 ethyl, and then the position of the double bond, you see 1, 2, 3, 4, 5, 6, 7. Then now here it will be 7-octene. It means that the double bond is at carbon 7. So you see, if you now say you will go with this, you even add, if after you add the number, you will see that they are higher. If you now say 7 plus 5, we have 17. Sorry, we have 14. And this one, 4 plus 1 is 5. So we always go with the lowest number. So that is why it's not even considered to count it from this carbon. Okay. Then the next thing after this is okay. Then the next thing is a compound with more than one double bond. If you have a compound with more than one double bond, So 2 double bond, you name it as diene with the position. Then with 3, it will be triene. With 4, it will be with tetraene. So numbers are used to specify the locations of the double bond. Like for example, if we have 1, 2, 3, 4, 5, 6, 7. So you see we have a double bond at carbon 1 here, and we have also double bond at carbon 3 here, and we also have it at carbon 4. So that is why we have 1, 3, 1, 3, 5 hyphen hepta triene, because they are 3. And if they are 4, like here, we have them at carbon 1, we have it at carbon 3, we have it at carbon 5, and we have it at carbon 7. So that is why I have 1, 3, 5, 7 cyclo-octa tetraene. So because it is cyclo, that is why it is like this. So I think it is very, very important for us to know that a single compound may have a multiple bond. So, and it's very, very important to indicate the position of that number of the double bond. So alkenes as substituent. So what if you have alkenes as a substituent? So alkenes names as substituent are called alkenyl, not alkyl. It's alkenyl groups, and can be named systematically as ethinyl, prophenyl, etc., or by a common name such as if we have ethinyl, ethinyl is vinyl. Prophenyl is Ali, and we have also methylene and phenyl groups. So you see, this one is methinyl, this one here is methylene, and this one is vinyl or ethinyl. But this one, it means that they are appearing as a substituent, and this one is allyl group. And we also have 2-methylene cyclohexene. You see, look at it here, because we have here we have a single carbon with a double one at position 3. 1, we start normally if you want to number this as a cyclic, you name this one 1. Sorry, yes, you count it as 1, and this is 2, and you count this as 3. So it is at carbon 3. Is the same thing as this. In this yellow structure is the same thing with this one. So that is why we say 3-methylene, then cyclohexene. Why is it that it is cyclohexene? The position of the double bond is not indicated, and it is because of 1. So that is why it is not indicated. Then another one, look at it. We have 1, 2, 3, 4, 5, 6. So the number of carbon here are 6. So it means that the parent name is hexene, but we have to count the position of the double bond. So you see, we have it at carbon 1. We have it at carbon 1 here. We number it, and we have 2 here. We have 3 here. Then we have 4 here. Then we have 5 here. So that is why if you now look at this, you see that, and at carbon, look at it, if you count it from here, 1, 2, 3, 4, 5, 6. So if you count it from this side, you see that the vinyl is at carbon 4. But we didn't take that one because it will give us, if we sum the number, it will give us the number will be high. So we will not take that one. But if we number it from here, 1, and here we have 2, and here we have 3, this one is 4, and then this one is 5, and this one is 6. So if we now count it, you will see that from here 1, 2. So it means that at carbon 1, we have double bond, and at carbon 5 here we have double bond. So that is why we have 1, 3 hexadiene, while the position of ethylene, which is vinyl, is at carbon 3. So we have 3 vinyl hyphen 1,5 hyphen hexadiene, or it can be 3 vinyl hexa 1,5-diene. So all these are correct. So we should also understand the alkene can come as a substituent. And this one is also very important for us to know that. Okay, then the next thing is cycloalkenes. Cycloalkenes